Today's math lesson is lesson 28, session 3, and I'm beginning this lesson on page 590. Now, what we're getting into at this point in math is we're going to be solving word problems about money. The last two sessions were about solving word problems using time. And it's actually kind of a similar concept, and we're going to see that we can use formulas and mathematical equations in order to help solve these word problems about money. So the example word problem that we're given and that we will further talk about in our learning phase is this. Prem buys 3 muffins at the school bake sale. Each muffin costs 75 cents. She also buys a cookie for 50 cents. Prem gives Mr. Hall a $5 bill. How much change does she get? So ultimately, this is going to end up being a subtraction problem because we want to know how much change Prim is going to get, or essentially how much she has left over. Now the book goes ahead and shows you how we could create a picture to help us understand the problem better. So in this first column here, we have 1 muffin, and each of the muffins, the problem said, was 75 cents. So it has been, quarters have been put in here to represent the overall cost. So we know that 3 quarters is 75 cents. And she actually buys 3 of those muffins. So we have 3 columns of muffins, each with 75 cents in them. And then she also purchased a cookie for 50 cents. So you can see right here at the bottom that you could simply add all of these amounts together and then subtract that from the total amount, or the total that she paid, or you can take what she paid and then subtract out each of these amounts to get with the amount that she has left over. And the second portion says, show the amount Prim gives Mr. Hall using bills and quarters. There are 4 quarters and $1. And Prim spends in all 11 quarters, because if we added all the quarters up at the top, we would have counted her 11. So they start by showing the number of quarters and crossing off all the quarters that she paid. So if I think of the first muffin was 75 cents, so that's 3 quarters, 1, 2, 3. The second muffin was another 75 cents, 1, 2, 3. And the third one was 75 cents, 1, 2, 3, and that leaves us 2 additional quarters to cross off for our cookie. And we'll find that we have 1 quarter left over and $2 bills that we are given back. So the amount that is not crossed out is how much she receives back, and that would be $2.25. Now that's how you can solve a word problem like this using pictures. Now we're going to get into a little bit more detail on how you can actually solve word problems using just standard algorithm math, really. So number 1 says the money Prim uses to pay is in dollars, but the prices are in cents. Which is the larger unit of money? So here you would consider, well, is a dollar larger or is a cent larger? And we know that dollars are larger because $1 equals 100 cents. And then $1 also equals 4 quarters. So we know that in this problem, the dollar is going to be the larger unit of money. And then the next one asks, how do you explain how you can convert $5 into cents? Well, if I know that for every $1 it's 100 cents, I could simply add up the 5 of these repeating, right, cents. So I keep adding 100 cents for 5 times. Or I know that if I have $5, if there's 100 cents per dollar and I have $5, I know that I will have 500 cents. So the number of cents that is in $5 is 500 cents. And that would be 500 pennies, right? 500 little pennies make up $5. So getting back to our original equation, this is how we can think of solving this problem using standard algorithm. And it says each muffin costs 75 cents. The cookie costs 50 cents. Fill in the blank to find how many cents Prim spends on 3 muffins and 1 cookie. So you can see that we can just multiply the 3 times the 75 cents And then we can add the 50 cents to that to get our total. So 3 times 75, and if I do that over here, 75 times 3, I get 15, carry my 1, 22, so that would be 225 cents. Is that one? 225 plus the 50, which would give me 275 cents. And then number 4 in this step says, show how to find how many cents Prim gets for change. So I know my total, excuse me, of cents is 275. And if I start with 500 cents, which I know by working out the top part here, if I start with 500 and then subtract 275, I get 225 cents left in change. And then when we're talking about cents, we know that we can move our decimal over 2 places, so that actually is $2.25 left over. Now number 5 says, you have found Prim's change in cents. Explain how to find this amount in dollars and in cents. Well, we really have not begun to add and multiply with decimals, but I think that we could at this time learn how to do that. And I also showed you over here, if we're just talking in cents, you can move the decimal over 2 spaces to get you the accurate placement, and then that's how we would add our money sign for $2.25. But now I'm going to show you mathematically. So 75 cents is really 0.75, and I know that I have 3 of them. This would be the 3 muffins that I have. And 5 times 3 is 15, and 7 times 3 is 21, and 22, added that in. So when you're multiplying with a decimal, however many places the decimal is moved over in the problem is the same amount you're going to move the decimal over in your answer. So 0.75 or 75 hundredths or 75 cents times 3 will give you a total of $2.25. And then when I'm converting my dollar bills into a decimal format, I'm given $5. So that's $5 and no cents. And I'm going to take away the $2.75, which is what our total was right up here. $2.75 I'm going to take away. And then when you are adding or subtracting using a decimal, the decimal place never changes. So you want to make sure that your answer keeps the decimal point in the same place that it was in your actual problem. So again, we get this answer of $2.25. It's going to be the amount that she gets left over. Now, when I was multiplying, what I forgot to do in this one is add in. So this represents the muffins. Those are the muffins, and then I would have to add in the value also of the cookie, which was 50 cents. So this is the cookie. And when I add that, I get $2.75 is what she spends. And so her change, when we take away what she spends from the $5 that she gives the cashier, this is her change left over. So there are just a couple ways that you can look through this when you are working out your problems in your book, but we have a couple more that we can work out together before we get to your independent practice. So now I'm on page 592, and let's go over these together. Aaron buys 1.5 pounds of cheese and 4 bottles of water. 1 pound of cheese costs $10. Each bottle of water costs $0.50. Aaron gives the clerk a $20 bill. How much change does he get? Show your work. So I know how much change is going to be a leftover problem or a subtraction. I know somewhere I'm going to be subtracting. Now, there's a lot of conversions that have to happen in this equation because we're talking about half pounds, and then we're talking about costing $0.50. So you have to understand that 1/2 of $1 is equal to 50 cents. Okay, so 2 quarters, 50 cents. And let's reread this. So Aaron buys 1.5 pounds of cheese and 4 bottles of water. 1 pound of cheese is $10. So I have 1 pound of cheese and a half pound of cheese. And 1 pound of the cheese is $10. So what would the half pound of cheese be? Well, it would be half the value of the 10. So the half pound of cheese is going to be $5. So I know the cost of the cheese is going to be $15. The cheese is $15. And I know essentially in my equation, and I can write it out, I can do cheese plus bottles equals my total. And then I will get put in the amount given, so the money minus the total is how much is left over. I'm sorry, let me do it equal sign, is what is left over or my change. So going back to the equation, I know that I have $15 that I'm paying for my cheese, and then also Aaron is purchasing 4 bottles of water. And each bottle of water costs $0.50. So we have these 4 bottles that are all 50 cents. Oops, 50. And I know that 2 50 cents together is $1, and another 2 is another $1. So my total here for the water is going to be $2. So at this point now, if I go back to my original equation, I have cheese plus bottles is my total, and that is going to be 15 plus 7 is my total, I'm sorry, 2. 15 plus 2 is my cheese plus my bottles, and that gives me 17. And now I have to take the money that I gave, which is the $20, minus the 17, and that will give me $3 left over, or $3 in change. And so I'm gonna write that down here, 3 in change. So there's many different steps that's required in these problems, so it's very important that you highlight and make sure that you understand fully what the problem is asking prior to trying to solve it on your own. Number 8. Keisha has $3,600. She uses $1,900 to pay rent. She uses half of the money that is left to pay bills. Then she puts the rest of the money in her savings account. How much money does Keisha put in her savings account? Show your work. So we have a couple here. We have, she has a certain amount. She uses or spends $1,900. And then she uses half of what is left over to pay bills. So then we're gonna have another number, and that's gonna be the number that she puts into her savings account. So this could be a simple subtraction problem, is probably where I would go with this one, because I can't arrive at half the money that is left to pay bills without subtracting this number from the total number of money that she has first. So I'm gonna put the amount minus rent minus half left over, and that equals, and that is what she uses on her bills, half left over for bills, and that equals what she's gonna save. So let's start just standard algorithm math doing this. So we're gonna do 3,600 or 3,600 minus 1,900 or 1,900. And she gets $1,700 left over. 1,700. So I had my amount, I subtracted out the rent, now I need half of this number. Well, so if you know that half, well, I know half in my head, but you could work with a couple of different numbers if you didn't already know it, because I know that if I look at this, what number times itself, or times 2 rather, gets me close to 17, and that's 8. So I'm gonna know that 800 gets me close to that, and so it's actually 850 is gonna be half, and I can just go ahead and subtract it too, half would be divide by 2. So 2 goes into 1 0 times, and then 2 goes into 17 at least 8 times. 8 times 2 is 16. I'm going to subtract that and get 1 left over, bring down my 0. 2 goes into 10 5 times, and then multiply that out. It gives me 0. I bring down my other 0. 2 goes into 0 0 times. So I'm left with 850 as being half for bills. So I'm going to subtract out the 850 for bills. Remember, this was rent. And the number I get will be the amount that she's able to put into savings. And I already know that that is half, so it's going to be 850, but I will mathematically do that for you. This is 6. Oh, I don't need to borrow that. Yeah, I do. Okay, so I have a 0, a 5, 8. So $850 goes into savings. And our final example before independent practice is number 9. Knox has 3 $10 bills. He spends $7.50 on a book and $9.25 on a pizza. How much money does Knox have left? So remember, he has 3 $10 bills, and I would want to multiply 10 times 3 so I know how much money I have. So he has $30, and he spends $7.50 on a book and $9.25 on a pizza. So here I think I would do total minus book minus pizza. Another strategy you can use is add the two amounts that are spent and then subtract that amount from your overall total. But I think for this one, because we don't have a lot of extra complicated math, it'll work fine just to do this. But don't forget that you needed to multiply your number of bills by 3 to get the $30. So 30 minus $7.50 is going to be so 0 minus 0 is 0, 10 minus 5 is 5. I bring down my decimal. 9 minus 7 is 2, and 2 minus 0 is 2. So I have $22.50 after I bought a book, and now I'm going to buy a pizza. Let me put it over here so you can see it better. $22.50 minus the pizza. And this will be 50 minus 25 is 25. And I'll show you that right there. And then we have 12 minus 9 is going to be 3. And then 1 minus 0 is 1. So what he gets back, what he has left, is $13.25. So after these lessons, you are now prepared to begin working independently on page 593 and 594.